Yeah, it's great to have this event because this is a fantastic topic and we have a great speakers. So first I will share my screen first. I have something to give to you because today's topic is very broad and then I have several key topics. So I'm going to introduce what the agenda and then set the stage and then try to give you the overview of the whole topic of today. Okay, so as you see that we have a three really like important topic like Agi AI and Agi computing, and then spatial computing and the metaverse. So this is the very fantastic topics. And then it's in the deeper level, we require like understanding of the very basics of the technology and their applications. So we try to cover as much as relevance for that one. So based on our agenda, actually, fortunately, we have three great speakers to cover in every aspect of this topic. So for example, we are going to talk about like edge computing and AGI, what they are and then how they drive. And then whether they are related to like IoT, blockchain, other digital technology, 5G or digital technology and network technology. And then we are going to talk about like what is industry-wise deployment. And then we are going to understand what is spatial computing. Maybe some of you may be not familiar with this terminology. And then we are going to talk about like how they actually relate to like the fundamental building block of the metaverse is like a reality technology. So what kind of like extended reality means that the virtual reality, augmented reality, and mixed reality, whatever, all the reality technology, how they are related. And then also we are going to talk about why the AGI is important for the spatial computing and integrate everything, right? So how they integrate to like to support metaverse applications. So as I told you, we have three speakers, Angelio, and Sam, and then Casey Simon. So they will introduce themselves when they started their talking. So we are going to have like a brief talk, a presentation as a keynote type. So each speaker to share the insight about each topics. And then we will join together as a panel. Then I'm going to moderate the panel discussion. Okay, so I'm going to set the stage because today's topic is so broad. So first, I wanted to show that what is edge computing, right? Because Angelio is an expert, so I'm not going to touch many things. I'm just saying that edge computing means that you are computing and storage resources cross endpoint, because you may think about like a data centers and the central cloud like a computing. But as we like deploy more and more like end user device like a smartphone or the IoT devices or the like other like in the very close to the like your application point, and then we need to move our computing power to close to your like application source. So that's the one thing. So we usually call like cloud-like computing. So they will edge cloud. And then we can think about this as a distributed computing. So distributed means that your computing resources all over the place at the edge, and that they can be collaborate each other, and they have many advantages to doing that. Maybe Angelio will cover this kind of topic. And then also they are very like related to the physical computing. It means that we are going to talk about the spatial computing. And in addition to spatial computing, we also have a physical computing that I will explain more about this concept. So why we think about edge AI? Yeah, definitely AI is a fundamental building for the intelligence application, right? So to include intelligence, you need AI. And then you can think about AI on the edge, right? So on the spot. So for example, in the smart, like a smart factory is one of the like the component of the industry 4.0. And then a lot of the like manufacturing process is ongoing in the factory level. And then if you like process something that relate to this kind of smart factories process in the cloud, they will take a lot of time because of the moving to the like your data to the cloud center and then processing back. So is trend that your computing power, it will be close to your like application source, and then AI also on board to the edge devices, and then they will process your data to get the intelligence. And then also I mentioned that as the AI can provide like in the distributed computing. So the like in the most important issue with the AI is to how actually the preserve the privacy, because sometimes they are dealing with the critical data related to your privacy or something like that. So this is one way actually the edge AI can provide the private using federated learning. So this is well known in AI community about how you do in the federated learning through this like a distributed computing source. And also like we are in Web3, so we try to do decentralized your like a backend data network. So we want to be like a computing sources on the backend in the decentralized, so no central governance of the your like govern your like computing resources. So they perfectly match with the blockchain-based decentralization. So AI is very important factors for even for the Web3. They are going to like a fundamental building block for the metaverse. Okay, so then I'm going to talk about what is spatial computing. So actually the spatial computing is a recent topic that the spatial computing means that extending computing power into space around us. So maybe it's very similar concept in the ubiquitous computing, like ambient computing that we have like a long time like have in academic and some like a practical level, but that's one extension of your computing power to the space, so that actually the interaction with the space object and environment. So you can imagine that why this is important, like for example, augmented reality, that you interact with your space and then object with in overlay with your like a virtual object in the augmented reality. So for example, so according to Wikipedia, the spatial computing means the digitalization of physical world to form digital representation of real world. So you have a very familiar with this terminology in metaverse, right? This metaverse is a combination, combines like a physical space and world and virtual world in a merged way. So they will be fundamental building block for digitalization of your physical world to make digitalization, and then they will be put into your virtual space, and then they will be combined, right? And then also they are more like the integrated reality technology, like a VR, AR, XR devices like that. And the most important thing to relate to the because metaverse is 3D models they can provide. They will be like scan your world and mapping it, and then they digitalize. And so they can build up your 3D model like environment object through this spatial computing. And then AGIs is very important because they will provide like contextual intelligence, means that they can understand your surrounding, and then they can read your intention, and then they will interact with the metaverse world in a like a cognitive and a contextual awareness. Okay, so this is one thing that I have in mind, because I'm thinking about the what is the best way to build up this metaverse infrastructure system. So this is one architecture. So basically, I've explained very shortly that the spatial computing and physical computing is a fundamental building block for the like a metaverse infrastructure. So they will be the computing infrastructure, and then they will digitalize your space, and then they will put in your like a space to the metaverse space, right? So they are very important. And additionally, that there needs to be like network environment, for example, 5G, 6G, or whatever in the physical network. Also, like for example, they want to be like a decentralized Web3. So you can imagine that in the metaverse, in the architecture way, the front end, like for example, you think about internet, the web like application you are doing in the World Wide Web, and say in the Web 2, and then you have a content, right? A content and a website. You can think about this that will be overlaid to the like a metaverse world. So 2D like a website, web content will be mapping to your 3D and then your environment object will be 3D, and you join as an avatar, your metaverse world. So it'll be like immersive, and all the object will be similar to your web content in the web 2, and then all the like surrounding environment will be your individual web page you visit, right? So in the front end, what you see in the metaverse world is similar to what you have seen usually in the 2D website, right? And very easy to understand, right? And then what makes this happen? Spatial computing, right? And then what provides the intelligence, but the intelligence means that you provide a lot of the frantic for like experience to you is Agi AI, right? In the back end, and then what can support it? For example, Web3, like a decentralized network, will be supporting this one in the back end. So this filled up the complete structure of the metaverse architecture. So that's why that we are very interested in the older topic like Agi computing, Agi AI, spatial computing, and the like how they actually relate to ubiquitous computing, also like metaverse, right? So having said this one, that I'm going to like start to hear from our expert insight about their individual view of each component, like what is the like edge computing and AGI, and the spatial computing, and how they relate to the metaverse. Okay, I'm going to stop my sharing. Okay, so it's time to have a time to hear from the great insight from our distinguished speakers. So Angelio, you are the first. Why don't you start now?
Okay, thank you very much. So I guess you should be able to see my screen.
Yeah.
Great. Okay, so first of all, thank you very much for having me here today. So as it was mentioned by Alex before, I've been involved with edge computing since the very beginning. And in fact, to be completely transparent, I was part of the group that started fog computing. Okay, so if you ever heard about fog computing or the Open Fog Consortium, so I was behind that. I was one of the guys that actually gave a definition to fog computing with some other friends at Cisco almost 10 years ago now. So what I'm going to do in the following slides is going to, well, maybe I hope will be a little bit provocative to make people to move the attention, okay? Because I understand that AI is fascinating, but my point will be that you have a brain, but there is not enough, and I will both make technical as well as biological analogy, because I think that for many people, and even there were some discovery on how fundamentally our brain is distributed in our body that are fairly recent, and I don't know how many people are really aware of that. And I think we should take into account these new discoveries when designing, systems, because the common assumption and vision that the brain is just here, it's rather wrong. But so, without further ado, let's get started and let's try to understand what are the key enablers for Edge AI, and then let's see how Edge AI is key for the metaverse. So that will be the construction of my talk. Again, the first point I want to make, as I was mentioned before, is that in our community, you hear people talking 90% of the time about the brain. Again, AI, okay? We do lots of research on algorithm, and now obviously there is increasing research on decentralized learning, but it's always about the brain, okay? The brain is absolutely fascinating, and I'm the first one being fascinated by it. But very often we forget that a brain without a nervous system is useless. Okay, I mean, just realize that, and we'll get to the technical analogy of it. You can have the most powerful brain in the world, but if your nervous system doesn't work, it's really useless. And it's interesting because, I mean, why nobody cares or is fascinated by the nervous system? Because, I mean, it's humble, it's there, it doesn't work silently, and you only notice it when it doesn't work, okay? But when it doesn't work, things start getting very complicated. So what has this to do with the situation today? So let's get technical now. So if we look at what is happening today, the reality is that we have an increasing availability of storage or opportunity to store data, to compute on this data and to communicate on devices that span from the data center, which might be public or private, down to our device. And like we saw in Alex's slides, that device could be my cell phone, could be my car. I cannot tell my watch because this is an ancient Tissot mechanical. So, but anyway, you get my point, right? It could be your laundry machine. But there is really, and with 5G, this continuum, right, will get really a continuum from the potential data center, some infrastructure that is closer to your end device and then your device. Now, some of the premises or some of the interpretation of edge computing is that you would like to draw a boundary somewhere in the system and decide what is the infrastructure, right, and up to which point computation is offloaded, and then the rest, it's just potentially not so intelligent, not so capable devices. The reality is that our interpretation, I think the interpretation we should have of edge computing is that you get to pick where that edge is. So the edge might be, once we will have 5G, potentially an edge server in the 5G network, either on a cell, on a nanocell, or a picocell, whatever that provides in terms of computing capability, could also be the computational capability or the server that you have on your car, because pretty soon we will have a data center on 4 wheels. I mean, we have been working with ARM on some of their latest processor. I don't know if any of you are familiar with the Ampere 80-core processor from ARM. I mean, the machines will have amazing potential for storing computing and with 5G also communicating. So you see that this spectrum and this continuum really gets down to our personal devices, and it would be really a pity not to be able to exploit it. We also need to exploit it to support certain use cases that require lower latency or that perhaps require better utilization of energy. Another point that I think we should all keep in mind, and it's very often neglected, is that power consumption is not just about data centers. Okay, data center, of course, consume energy, and it's great to have green data center. But if you look at the energy envelope, most of the energy is consumed for communication, and that has to do with physics. Communicating takes far more energy than computing, and that has always been true. And there are some pretty astonishing number available as far as you make a search, but I'll give you some pointer. So the first one, and that was something that got me thinking a lot. But some of you are maybe familiar with Despacito, which is a video that reached for the first time 1 billion views. In doing that, only for communication, okay, so distributing this video from data center down to end devices, it consumed as much energy as 40,000 households in USA use in 1 year. I mean, this is incredible. And if you think some of the consequence of this high energy usage is because each time this video is distributed, right, is distributed from a central infrastructure or not so capillary distributed infrastructure. In other terms, if myself, Alex, and we're sitting in the same room, right, and Laura were sitting in the same room, if I'm watching the video, is watching the video, and Laura is watching the video, best case, we are getting in from a content caching network, but we are not sharing between us. And there are technology that will allow us to do that. So once again, we have to change the way in which we think, not just because of performance, but also because of energy impact. But then the hard reality is that the existing technology that represent our nervous system, right, for then supporting, for instance, AGI and everything else that requires it, which are the data management technology, really falls short in dealing with data in motion, data at rest at this scale, and with providing us uniform abstraction to sharing data in motion and at rest from the data center down to the device. If you pay careful attention, most of the technology available today work well either in a cloud-centric environment or in a completely decentralized but isolated. And that's not just good enough. And as a consequence, this severely hinders the applicability of AGI. I mean, we might have the best algorithms, But until we want to have a data, a nervous system, so a data management technology that allow us to support such brain, I mean, life would be quite complicated. And I want to give another biological reason for this. So many people think that our brain is here, and you couldn't be more wrong, because if you look at evolution, our first brain, and in this word, right, the Chinese, was in the belly. Okay, and in fact, in the belly, we still have as many neurons as there are in a dog brain or in a 3-year-old kid. I don't know if you realize. Okay, and there are already some theory that essentially explain how potentially the brain that we have here started really developing when the effort and the complexity of our digestion reduced because of the invention of the discovery of fire. So digestion is increasingly complicated. And as you know, we really have two brains that are actually directly connected, influence each other. But that's not enough. If you think about muscle memory, or even the reaction that you have when you get burned, I mean, it's not a reaction time that comes from the brain. That's intelligence that you have built on the periphery of your system. So we have to reevaluate our understanding, of a complex entity like human body, which is, it seems centralized, but actually is far more decentralized than we believe. And, what keeps everything together and working well is the nervous system. So I think we should go back, and putting more emphasis on having this good nervous system to support this decentralized intelligence. And so far, I think this has been underestimated. Our company is working on this, obviously, because we've been always, sensitive and sensible to this point. I think the level of appreciation of the importance of this element is growing, but this will be essential going forward. And now, if we move to the relationship between Agi and Metaverse, I mean, I will argue that Metaverse, at least the Metaverse that is interesting from my perspective, will be hard to exist without some form of edge computing. And as we will see, the level of edge computing that will be required to support Metaverse will depend on how much this Metaverse needs to be real. And we'll get to that in a moment. But even without considering the reality aspect of the Metaverse, and I will get that in a moment, if you just consider the amount of data and the level of interaction required on the Metaverse, especially when we have physical proximity, that will require some form of good decentralization, thus edge computing, edge AI, and so on and so forth. Then what do I mean by real metaverse? For me, real metaverse, which is the interesting thing, is really an augmented reality, okay? It is completely immersive, and of which you could have 1 trillion interesting and useful application. In that case, right, once again, think about our perception of the world. I mean, our perception of the world per se is a metaverse, right? Which we build inside ourselves. It's a representation that we build. And then the way in which we operate is that our reaction time is compatible with operating and keeping ourselves alive in a real world, which has to satisfy the law of physics. Laws of physics have to do with time. Okay, you have to buy certain response time. I put hand of fire, I don't remove my hand from the fire quickly, right? I get heavily burned, right? On a non-real world, that is not a real constraint because this aspect of time is more fluid and virtual. So I think in a metaverse that really aspires to be an extension, an enhancement, and an augmentation of a reality, then having the ability of capillary distributed computation and AI will be essential. And I think this is really where we should lead. So that concludes my presentation. I really wanted to give, a different spin on this. I hope that was, we'll fuel some discussion on the panel session. And I thank you for your attention. Thank you very much.
Thank you, Angelo. I think that you give the very good insight about what will the future metaverse like infrastructure, because you mentioned about like where the energy consumed, right? Because not just for the processing, but the communication.
Correct.
Right,
And
that's
again,
very important point.
And energy is super important, and people neglect that decentralization actually helps with reducing energy consumption.
Right, because energy consumption is directly related to the carbon emission, right? And then it is related
Absolutely.
to
Yes.
sustainability. That's Laura and me, or another is a good, a great topic. So
And again, I mean,
we are doing that.
even if we communicate over 100 gigabit network, right? One thing is if I
Right.
make one hop, one thing is if I have to make 30 or 50 hops, the energy envelope will be completely different. And this we never count for, which is like cheating for me, because that's where most of the cost is.
Yeah. Maybe we can discuss in later, but because I'm not planning that. I'm not working with several other people. Usually, my first job was telecommunication area,
Mhm.
and then I starting from 2Z quite a long time ago in South Korea. I was a government officer to deploying 2Z, and then I worked for the 4Z as a government officer, and then I still working on 5G, 6G, and something like that. They should be integrated with edge computing, right? Is in the future of the metaverse infrastructure, and then
Yeah.
we also should care about the sustainability. So I call like a sustainable infrastructure. So that's a topic that I'm going to have attention and then get some global forum next month. But I thank you for your insight. It will be a great insight that I can help me to like design what will be the sustainable infrastructure architecture based on your insight. And then additionally, that we have in mind that because edge computing, it looks like they are they are thrown in the like a physical entity like a smartphone IoT, but we can think about the metaverse. They can be embedded in the metaverse,
And they
right? So
should. And they
yeah,
should.
as AI on the like metaverse means that they should not be like a physical entity crowding. Maybe the like metaverse like edge computing, right, in the metaverse on site. So that'll be another like insight that we can have. Right? Thank you. Okay, so next will be Sam. Why don't you start now?
All right. Thank you, Alex, and thank you, Angela. It was very good. I remember working with guys at Cisco 10 years ago on fog, back when I was at Freescale. So it's yeah, these concepts have been around a while.
Absolutely, yeah.
Let me see here. Edge and cloud. I think this is, yep. So I've been working in computing and processing semiconductors and systems for several decades now. I'm currently working for FlexLogic's technology around edge AI acceleration and being able to support the kind of processing that's required to support AI type applications at the edge. And I'll talk about the kind of new paradigms that we're engaging in here. So let's see if my page will advance. I grabbed a couple of pictures. Actually, this picture of the clouds I took on my commute to California last week. And I just thought it was a pretty picture of clouds. I wanted to share that, but I also wanted to use this to talk about kind of clouds and edges, right? Clouds are, they are in a sense far away from the ground where the computing occurs, right? Where we engage directly, more or less directly with hardware. So when we talk about the edge, which I can remember talking about fog versus edge and, the merits of those terms, but, the edge does represent something that's much closer to the physical environment that we're dealing with, right? It's especially when we're talking about edge AI, you care about latency, you care about the interactivity of the application, and some things, speech-based systems, clearly we can tolerate the kind of cloud latencies associated with making a vocal query to a system and having that processed in the cloud and coming back. That level of human interaction we're okay with. But when we talk about vision systems and increasingly compute systems where we actually have devices that are operating in an environment and interacting with each other and interacting with people, then the importance of that latency becomes paramount. And as Angela mentioned, the communications bandwidth power dissipation also come to bear. So, if you go and look, and there are various websites, you can go and look at the latency to various cloud services. Sometimes you'll find kind of single digit milliseconds. I don't think you'll ever see anything less than a millisecond, but kind of this tens to few hundreds of milliseconds are what one expects anytime you send data to the cloud. And that latency is not a round trip. That's just how long it takes to get from here to there. There's processing, and then there's a return trip, right? So there's time it takes to communicate to clouds. Clouds are very, obviously very powerful, but there is a latency aspect that cannot be ignored. And especially when you're talking about things like inferencing, right? If I'm inferencing like a vision-based application, and I'm trying to do something at 30 frames a second, it's 33 milliseconds to process one frame of image. So if I'm, going to the cloud, then I'm already going to introduce several frames of delay with the transfer latency associated with cloud. So that becomes something that people do care about. I think it's always been, I think everybody takes it as as a basic common sense that you can't have autonomous vehicles be dependent on a cloud for latency and just overall kind of network reliability reasons. So now once you understand the latency, the next thing to understand obviously is the bandwidth and what bandwidth is required and what you're paying for that bandwidth. So, compressed video streaming, HD video, it takes time to compress and decompress video as well. But so assuming that you're able to compress that video, then you're looking at kind of, 5 megabits a second. Not too bad for an HD video, but over the period of one day, that's 13 gigabits. And so you start talking about, you need to have gigabit class links to support the latency and the quality of service associated with it. So, a lot of cloud services like AWS, inbound data is free. You can send as much data as you want to the AWS cloud, and it's essentially free. Outbound data, they do charge for. And within the, system to system transfers, they charge for. And then if you were getting, a business class internet gigabit link, then that's going to be about $1,000 a month. So there's latency, there's the bandwidth, pipe sizes that you need, and then there's the cost of supporting that. So if I go look at, and I took this directly from the AWS pricing page on their Elastic Inference. So Elastic Inference means, it's the elastic computing with inference accelerators to do inference type processing. And when we talk about inferencing, that's really the usage of machine learning or artificial intelligence models on special accelerators in the cloud. So to run a deep learning inference to analyze a single video stream, and like I said, this is straight from Amazon, then you're looking at essentially 17 cents an hour for the compute instance, another 12 cents for the accelerator, 29 cents an hour for the use of that combination. So that's $215 a month if you stood up a system and we're using that to process something. So that maybe that sounds like a lot of money or not, but on an annual basis, it's the cost of a fairly well provisioned computing system. So, yeah, you can pay as you go, but ultimately you're going to pay for the processing for that. And additionally, you'll pay for bandwidth and other things. So it's a good, it's not free to process in the cloud, I think is the message here. And then the question is, okay, where's the best place to do things? So as we look at the edge, the challenge at the edge is that you need so much processing performance if you're doing AI type applications. So one aspect of it is the software complexity. So when we talk about machine learning models, they're very complex models. They have hundreds of layers and there's a lot of very specialized operations that are performed, and it's not software that is, you really have difficulty writing these programs in like C, in a C programming language. So you need these more abstract languages and libraries. You're using things like Python as a framework with specialized libraries to represent the operations, and then there are various mechanisms to kind of represent this level of complexity, because we are processing teraops of trillions of operations, and there is inherently a lot of parallelism that you cannot get access to in traditional programming environments. So you need new paradigms in terms of software to expose that parallelism and be able to map that onto the various hardware structures to provide that. And then I'm representing a company here as well. And the problem we're trying to solve is, how do you fit that level of processing in a power envelope and a cost envelope that makes sense at the edge? So how do you fit that high amount of processing and get that to a point where it can be economically interesting for customers to use? So I wanted to spend just a little bit of time talking about this concept of teraops, and Angelo is, he had zettaops. Zettaops is several orders of magnitude, maybe 10 orders of magnitude beyond where we are in teraops. But if we think about the amount of processing that's required, we could sit here and count seconds, and we know what that is. 1 million seconds is about 2 weeks. 1 billion seconds is about 32 years. And a trillion, or a terasecond, is like 32,000 years. So we're very comfortable with the transition we've made in computing technology from kind of the mega scale to the giga scale, which is where we live now. Most processors run in gigahertz, and there's some parallelism that'll get you to, tens of gigahertz of performance, or tens of giga operations of performance. But to really get to teraops and beyond, you have to have different architectural approaches. Now, fortunately, the teraops that we're talking about have highly regular structures and are able to be exploited with a lot of temporal and, a lot of real spatial parallelism. There is a temporal sequentiality to them. In other words, there's a whole lot of parallelism that you can take advantage of, but you can't do everything all at once. There are these layers that you pass data between that require require things to be completed in a certain order. But it is in aggregate teraops, and especially if you're trying to fit it in a headset, or you're trying to fit it into something that is able to sense an environment, a real-time environment, you've got to shrink that down in something that's very, very efficient. So I'll just talk a little bit about kind of what we're doing to try to solve that problem, which I think is an important problem to solve when we talk about the metaverse and the sensing. So there's two aspects of metaverse. If we're talking about metaverse, hopefully we're talking about something that's going to be fun and engaging, not the Matrix, more like the Oasis. Something to be fun and engaging, but you've got to be able to move a lot of processing performance very close to the user for the latency discussions that we just had, especially in the interaction with the environment, right? So the sensing of the local environment, and then the rendering of that information, right? So whether that's through graphics processing units or other things, we do see essentially that the processing for the GPU and the processing for the inferencing are different. You can use GPUs for inferencing. It's not that efficient to do that, and there are other structures that are much more efficient for inference level processing. And we're not even talking about the training aspect these machine learning models, which we think of is mostly a cloud problem. But the concept is that you're able to significantly reduce the size of the processing required to create silicon solutions that are able to run the software required at this. And so in a comparison base, I think this is my last slide here. The comparison is that I can, versus an NVIDIA GPU processor, I can kind of process more performance with a much smaller piece of silicon. And that much smaller piece of silicon directly translates to saved cost and lower power, and the ability to use that into much much smaller systems because of that, because the power is lower, the cost and the requirements are lower. So that's kind of what I wanted to bring to the party here, so to speak, is that as we move to talking about metaverse, we have to recognize that the processing, the computing, which I think of as a more general purpose, right? Data processing, computing, and then the inference processing or the graphics processing will become more and more specialized in order to interface at the edge, and then you'll have this set of computing resources moving up to the cloud that will have more and more power, more and more connectivity. But as you get close to the edge, most of the processing will be focused on the direct interfacing with the kind of individuals or other devices there at the edge. So that's my 2 cents. Hopefully we can discuss some more in the panel.
Thank you, Sam. I think that's a great insight because realization on the metaverse will not be happen without like a supporting infrastructure, and then your innovation is very essential to have at the edge. We need to like computing power to like supporting, and especially it was fascinating actually. You can think about the current like NVIDIA GPU. Because I'm using my computer as a game machine, so I have a GPU like 11 gigahertz like a GPU inside of my computer, and how bulky it is now. And then so we needed some kind of GPU type processing at the edge, and then I'm fascinated by your like innovation to bring the attention to that. Okay, so next will be Casey Simon. So he is expert in spatial computing. So next our site move from like edge computing to spatial computing.
Yeah, thank you so much for having me, and really, really lovely these last 2 introductions. I think really set the stage well. Yeah, so I'm based at the Technical University of Delft, where I'm a researcher of spatial computing, and I wanted to kind of just really address what spatial computing is. So as a researcher, what I look into is how spatial computing is created from the engineering all the way through the design side. So I try and make sense of the processes and methodologies that go into creating spatial computing artifacts, so that we can actually create new kind of ways for this industry to move forward in methodological rather than kind of, yeah, it's a little Frankensteinish right now, which is exciting, right? It means there's a lot of innovation, but it also makes it hard to track where we're going, where we want to go, and how to evaluate it. So I kind of compressed a talk that I like to give on kind of the very brass tacks of what is spatial computing down, and then added on a little kind of addendum about like how does this exist in the metaverse, and thinking about bringing the computing power indeed away from the cloud and into the edge as a kind of core need, I would say, of spatial computing. So perhaps you guys are familiar with the concept of computing waves. Computing waves are kind of a term that get thrown around a little, I don't know, rough and tumble, and they emerged in the 90s. I think Alex was saying earlier that he was even involved in kind of early conversations about ambient intelligence. And so Mark Weiser is kind of people say that he started this term, but it's a little unclear. In any case, in the 90s, we start talking about computing waves, and computing waves come from a thought about innovation waves, which came from a Russian economist who was noticing that when innovation comes about, they happen in cycles, and they happen at a certain rate that kind of has a peak and a valley like a wave. And here we have the same phenomenon happening with computing technologies, and they're broken down by the amount of users use any single type of computing device simultaneously. Of course, our very first computer, the mainframe computer, kicks off the computing wave and really never hits even close to 1 billion devices on Earth at any single time. And it's really one computer, many users, and it has currently very few functions, though I've done quite a lot of research and they do still exist and they are still produced because they're quite expensive. So if you've invested in one, good reason to keep it around. Of course, we move into desktop computers in about 30 years later, and this kind of brings the idea of where can computers be into question and starts really a new revolution. You can see an interesting kind of dent here in the mid 2000s where these desktop computers actually go down in sales per year. I wonder if any of you guys can think what the reason is for the uptick. It turns out it is gaming. So desktop computers do still have a very active function in our current computing infrastructure and probably will maintain one, unlike the mainframe, which we will see. And then we move into ubiquitous computing, and Alex did indeed mention this as well. I find this advertisement incredible, as if all of us were going to lug literally a piece of luggage to work just to have a personal computing device. But of course, in the 80s, what we see happen is that the power of computing is changing in a way that, okay, theoretically, sure, we could have more computers serving a single simultaneous user. Of course, you have your phone, your tablet. We know the story where this goes. Servers are also seen as their own independent computing wave. It is incredibly challenging to get accurate numbers on how many servers there are on the in the globe right now, because of politics, etc. But the function of a server, as we all know, is to, many computers, many users simultaneously. Why do I think this is important? Well, the term ubiquitous computing, pervasive computing, spatial computing, mobile computing, these all get thrown around kind of together. Hello. And they all have distinct meanings and also, importantly, a little bit of overlap. And so the distinction between pervasive computing or mobile computing or spatial computing is not, is this okay, Matilda? Okay, dogs and children. So yeah, there's some blurry edges, and so something can be a pervasive computer while it's a mobile computer, and we'll talk a little bit more about those distinctions and how they work. So in practice, what we found is that this turns out to be a pretty good working definition, and it's interesting. I know one of our earlier speaker, Angelo, was talking about using biological metaphors as well. So the working definition we use is spatial computing is extraceptive computing, comprising of an array of software and hardware, working in tandem to track events in real Euclidean space. So extraceptive might be a term that's new for some of you. It does indeed go back to biology. And so biological organisms have introceptive, extraceptive, and proprioceptive capacities. Introception being the ability to kind of be internally self-aware, conscious or non-conscious. Things like knowing your heart rate, which we don't really have as humans a conscious awareness of, but of course that is happening. Proprioception is your awareness in space. So that's your equilibrium, balance, et cetera, kind of having a sense of distance. And your extraception are basically the majority of your 5 senses. So your awareness of the environment. And so in this way, we can kind of group all, spatial computing things into this definition that the computer itself is aware of its environment intentionally and centrally, whereas something like a desktop computer, right, is actually more aware of its own internal environment as the computing goal. Okay, so another nested category within spatial computing. So there's a lot to digest here in terms of images, but often when folks talk about spatial computing, they talk about it in terms of this kind of vague difference between we all know VR is, right? That is a clear separate thing, but then we get into AR, MR, XR, and the lines get blurry. Is that what the metaverse is? Is it the seamless movement between the three? So in my research, I like to look at it actually in terms of mobility of the spatial computing artifacts. So on our automobile category, we have things like drones. Snap just released a new drone that takes a selfie. Okay, maybe a limited use case, but we're starting to see that, yes, this is a tiny computer with a lot of extroception, a lot of awareness of its environment, and the task is quite small. Take a picture. We also have our Roombas, of course, or startups like UX, which are self-driving vehicles. Your mobile is an interesting category because the way that it becomes mobile mostly is just through the use of human, movement. So by wearing augmented reality glasses, I've created a mobile computer that is a spatial computer, or just using my mobile computer, a tablet or a phone, I've created an augmented reality experience like with Pokemon Go, or here we're at the Apple Store. And then VR is a clear it is spatial computing for two reasons. And I don't think most people don't refer to the three-dimensional visual element of a VR headset as spatial computing, but some people do. But importantly, the movement tracking to help you be naturally in the experience of VR, that is very, very much spatial computing. And then the immobile is an interesting paradigm where you are more relying on an array of hardware to together create the paradigm of spatial computing. So something like an Amazon Go store, is every single sensor itself spatial computing? Possibly, but possibly it's computer vision, and that happens later in the software side and not in the hardware side. And so this gets blurry again, but in any case, these are fixed uses of spatial computing. So yeah, how do we want to get into spatial computing? Well, this morning, or the last 24 hours, Figma, which is for those of you who are not familiar, Figma is a kind of new competitor to the Adobe suite of graphic design products. So they had a conference, and this is Bill Gikaran, and he is the head of IKEA Smart Home Smart. And he said, what do we do when the internet fails in our smart homes that we've created, beautifully designed? Now the internet's gone, how do you access your home? I think this is a really real question. And the reality of, do we send it all the way up to the cloud? Well, it doesn't work when the internet goes out. How do you turn on the lights? There are immediate use cases, of course. And I thought it was interesting, the two earlier speakers were asking, well, where actually is this edge? Is it at the device level? Is it at the node level? Is it right on the edge of the cloud level, right? These are different places. And I think that's going to be a very, and what we're finding in our research is it's a very important question for engineers and designers alike to have a really clear grasp on, because otherwise they're designing and stabbing in the dark and creating protocols that maybe actually don't have fail-safes built in. So when we go back and look again at this assortment of technologies, my sense is that this is the metaverse. And it's the interaction between these things in a seamless way that allows us to access the metaverse, less so than the central VR idea that once you're in that digital space, you're in the metaverse. I think certainly as we're discussing it today, it's really about this transition between these objects. So yeah, hopefully that was a nice little semantic conversation, but glad to be more, at the interstitial hereafter. So thank you.
Thank you. Yeah, it's a great insight, because first that you mentioned about is a migration of the ubiquitous computing to the spatial computing is very important, right? And then also we are living in the spatial, right? So we are in a spatial, so human is adapted to be spatial. So I think that the spatial computing is a natural way to supporting our insight about the environment and our interaction with the object. And the other thing that you point out, seamless, move around virtual space to real space through a mixed reality type, right? Because that's very important. And then you provide a very, very good good example about what the future life in a metaverse, right? For example, you have a XR device type glassware, right? And then they have to communicate with ambient, with tap the computing power like in the edge computing, and then they will be seamlessly move. For example, if you move around a shop, and then they will overlay with your physical shop around to your virtual shop. For example, that if you look at some product, and then they will provide like information and virtual information and what the like for example they're linked to the web3 NFT, and then you have a bonus if you have like a buy there or something like that. So it will be give you like a completely merge between the real space and the virtual space, and then seamlessly like crossover, right? For example, if you're in the home, and then if you like wear this kind of the extra device, and if you're looking at the like for example your TV, right, and then you can control through your device. It is a physical control, but also you want to move into the virtual space, and you can control your physical TV in the virtual space through this spatial computing. So that's a very, very great like a concept that we need to have it. Okay, so having said that, we actually almost time to like to move into the next stage. So we are going to join with our 3D speaker as a panel, and then we are going to, for example, that I think we like active participants. So we will have like a question from the audience to share your comment, idea, or some of the question. And if you have a pinpoint some speakers, you can do that. So I want you to participate in actively. And also like if you don't have any question, then we'll discuss about in the general this topic that we introduce in the agenda. So why don't you participate? Like, because we have several questions already in the chat window, but you can talk directly, and then you can share your idea or comment or question. Is there anyone to talk about? Because for example, Diana, you mentioned about like IBM has just developed a chip embedded with AI. What impact would have on the metaverse and the edge computing? Maybe the Sam will be the person, maybe the answer for that. Yeah. Yeah,
well, it's an interesting question. I think the reality is that that most chips, most processing solutions will have a combination of general purpose, kind of core-based processing plus AI acceleration. If you look at all of the chips that Apple makes for their iPhones, they're 100% penetrated on AI acceleration. In addition, they have ARM cores that they use to run iOS, run the, essentially all of the management of the phone, but they've added special acceleration blocks designed specifically to offload this the mathematics required to do AI processing. And the same way they have GPUs to do the screen-based processing. So it's really emerging as a new form of processing. There's still a lot of innovation in that space, and we haven't yet settled on what are the long-term winning strategies. And so there's there's still a lot of people trying to figure out how best to solve these problems, and the models, the AI applications themselves continue to evolve. So in a sense, you're kind of chasing a moving target. But yeah, it is very much the case though that the processing required is unique enough and different enough from general purpose processing that it will be, there will be special silicon acceleration techniques that are applied to do it, because it's just not a.
Hey, Alex, I've got a quick.
Yeah, okay, go ahead. Yeah.
Thank you for the presentation today. Quick introduction.
Way inefficient.
I'm sorry, did I speak over the top of you? I'm sorry.
Yeah, no, I was just wrapping up. Go ahead.
Okay. Thank you for that. I'm a global principal at Equinix. Equinix being a large global data center interconnection company. Quick question for the panel. If we were to think about and plot a time horizon as to when and how long the community, the world, the markets could take advantage of this type of pervasive edge computing, what kind of time is that, you know, just in the sense of developing and really being pervasively available. I just don't have a good sense of how long that's going to take for adoption.
I'd be happy to kick off an answer for that. I think, unfortunately, the answer is it's going to happen gradually over time, which is to say certain things are already capable of it now. And the interconnectivity element is going to probably take several decades to figure out in any meaningful capacity. So maybe I can clarify the question back to you, which is what kind of paradigm are you meaning when you're talking about this fully immersive, pervasive type of computing? What's the vision that you're speaking to?
Well, yeah, that's another, you know, great point. You know, I'm a member of the Evolving Edge team here at Equinix, so this is the types of things that we spend a lot of time thinking about. And as we did here, we open up every conversation with the definition of the edge from multiple different points of view. So the edge is defined by all of the different stakeholders and participants. And so I think, you know, my vision of this tends to become sort of a blended vision for what applications or what, you know, use cases get implemented. And I'm not looking for a common denominator. I'm looking for, what we're looking to do is to ensure that that folks can take advantage of the things that we're doing to meet the widest amount of use cases today, and be prepared to agilely take advantage of the advancements and the evolutions that take place over that long, you know, time horizon.
Yeah. Are you familiar with the Spatial Web Foundation? So they're working to create protocols with W3 for spatial web connectivity. So I think following some of the kind of most immediate use cases that they're actually creating, well, not legislative, but body controls around what to create protocol for might be an interesting way of kind of following what can we do right now and what is being prepared to do at scale. Yeah, that would be, but I'm curious what the rest of the panel would say.
Yeah, so I think there are solutions, at least for what concerns the data plane. There are solutions that are emerging. And I don't know how many of you are familiar with the Edge Native Working Group, but we have at least one technology that was designed precisely to address the problem that we're discussing. This is called, it's an open source project called Eclipse Zeno. And the bottom line, for those that are not familiar, maybe I'll give a quick idea. But the bottom line, what we managed to do is to try to merge the best, let's say, you know, experience that we had in protocols for dealing with data in motion, like PubSub, but PubSub that could span from a microcontroller and to work on a very constrained network and constrained hardware up to the data center and, you know, saturate a 100 gigabit network. With NDN protocols. I don't know how many of you are familiar with NDN protocol, but that comes from the NGI initiative, so Next Generation Internet. And those were protocols on how to query data that is situated on geo-distributed data storages. So this really integrates data in motion, data at rest, as well as computation from the data center down to the microcontroller. And I think it's really the fabric that is used. And there are quite a few European and initiatives around the world that are building on top of this technology to do Edge AI. So check it out. It's called Eclipse Zeno as a project. It's open source, and you know, there is a forum on Discord where you can ask questions. And there will be, by memory, the first user summit, both in person and virtual, on the 16th of June. So this will be announced soon, but it will be in Paris. Okay, but you still can attend either in the beautiful Paris or virtually.
Thank you. I think Nodri, I think that you maybe attend my next webinar is about the metaverse infrastructure building. I think that what you mentioned about really important, like a conference to build up the metaverse infrastructure, especially related to the spatial computing and edge computing. So I will invite you. Okay. Okay, so next will be I will have Amit Kumar. Are you there? because his question is not a comment about like he mentioned about the full-blown metaverse experience coming in a few years from now. So I'd like to hear from you that why you think about this.
All right. So hey, this is Amit Kumar, and yeah. So essentially, when the metaverse term came in, everybody said it's VR. It's just coining it as metaverse, and a lot of us said that VR didn't fly that much, so they had to put up a new term out and have technologies around it. And essentially, VR as we cannot see metaverse as VR, because metaverse is not just VR. It is going to expand beyond VR, and it will be more like where it's not just going to be virtual, but it will be real virtual together. That would be metaverse. So when we see that happening, all these new, my comment over there on the chat was more on the IBM hardware that was launched as a question where the IBM chips, the SoCs are now having, AI capability and all that, right? So I think a lot of AR and VR experiences that we would see in future, they would definitely be benefited by all these chips on the edge compute side, but it's still going to be time. A lot of solutions are evolving at this stage. For a full-blown metaverse experience where AR and VR and connected computing where human and machines are working together in tandem, these things they'll take too many new technologies to bring a full-blown metaverse experience. So I would say that my take is that all these chips can be really helpful in thinking about new solutions, and people can look at all ends of the spectrum, right from the end compute side to the edge compute side, and also the hardware. Today, if you see, there are only a few hardware companies who are making hardware for VR, and the same applies for AR, right? So I think if you see where we are going from here, the experience would the whole, when I say metaverse experience, like it has to be seamless. Like if I am using the metaverse or I'm in the metaverse, I should barely be able to figure out whether it's real or not real, right? So I think it's still time for that to happen. But in the interim, there'll be too many new things that will be coming in. And these IBM chips and the other companies which are releasing the new socks on, which have blocks of AI and everything else on it, they are just a starting point. I would say that is what I was talking about earlier on my comment.
Thanks, Armin. Actually, you get the point about the experience because just yesterday I published my article about the metaverse experience, so it was a timely question, and then inside, yeah, because for example, the Gartner evaluated for example by year 2026, at least 1 hour every people will be staying in the metaverse to enjoy something with the metaverse experiences. So so how actually the fully grown metaverse experience is not yet, but the important thing is that everything should be support infrastructure, like hardware, software, and then also how we actually design the providing this kind of the metaverse experience is very, very key point. And so I think all the effort we need to effort into giving to the to how integratively provide this kind of the metaverse experience. So I thank you for the good point. Okay,
there's
so
one thing more. There's one thing more, Alex. What I was saying is that I think metaverse from my perspective, it's totally my perspective. I think it's mostly going to change the dynamics of entertainment, what people want to have as entertainment in their lives, right? So if you look at all the latest, web content that is coming in, all the web series and stuff like that, content like Upload, which is coming on Amazon Prime, all these things talk about a virtual world, where you are real yourself, but then you can, enjoy the things that you cannot do otherwise, So I may not be a good basketball player myself, but in a metaverse, I can be Michael Jordan if I want to be, right? So I can get those skills and I can play basketball over there. So I think a lot of this stuff is very exciting, and this also would be changing the way we will be living in the next few years from now, because instead of just hanging out with friends, hanging sodas and beers, we would be hanging on the metaverse and maybe just meeting people over there, and finding new connections. So things are exciting. And I think all this new hardware change, all the hardware changes, and even the quantum computing that is coming in a few years from now, it's still very experimental at this stage. But as soon as this really goes mainstream, we will have a new world altogether, I would say, around us. You know, it will be not what we see today, but it will be very different from what it is today. So with that, I just
yeah, that's a great point. You know that what you talk about is in the conceptually means that in a like, for example, the virtual space, the virtual world is consists of the like a time and matter and then place, right? So it is 3D, and then there is a 3D object environment, and then the timeless. So we call like they will democratize your world, right? And then for example, that you mentioned about you can be anything in the virtual space, right? And then additionally, that the Casey Simon talk about, if they can be connect to your real life, right, in the physical world, it'll be add more values, and it will be greater power. And then that's why we need a spatial computing, right? Because that will bring you enable possible to be connect to your virtual space and real space. So that's a great point. Okay, so we will move on to the next one. Is Letna Deep talk about what is the biggest block for the spatial computing to take off and become mainstream. Maybe Casey Simon, the question for you.
Sure. That is a good question. I mean, I think it kind of goes back to Rodney's question as well, which is, what do we mean for these technologies to hit full stream? I mean, the vision is really, really grandiose and really, really all encompassing. To bring mobile technology into our reality was kind of a more discrete goal. We have devices that fit in our hands, in our bags, and have very discrete use cases as well. I mean, I think at the end of the day, you can boil down what mobile devices can do to accessing the internet and taking photos, which is one of the kind of those, I would say, are kind of the biggest use cases. Maybe having a security object on your person to keep on touching and be like, oh, I'm still connected. Spatial computing is so much more vast, right? We have the integration from your drones, personal drone assistants, to robots cleaning your floors and maybe bringing you things. In supermarkets, Walmart has a manager robot which goes through the store and checks stock. And then we have self-driving cars. We have fully immersive environments. So Amazon Go is a concept where you can walk into a supermarket and walk out without ever checking out, because all of the computer vision actually monitors who you are, keeps it attached to your account, and lets you walk out of the store. Yeah, how does that become is that whole vision all becoming true in every single context? Which is to say, is a school completely like an Amazon Go store, grades aligned over 17 different years, and every single piece of homework that you ever turned in be attached to you in some meaningful way? Yeah, that's going to be really hard and really far away. So I think probably just like mobile technology, the first thing is like, is it working well? Does it feel good to use? People didn't have a ton of Roombas when they were kind of not really reliable and you had to go back and vacuum up your floor again. So when we have these experiences that get increasingly easy to use, more of it will happen. And this has a lot to do with what Angelo and Sam, of course, was speaking to, which is like, how do we literally make that happen in terms of both the hardware and processing capacity? So they're working in tandem, I think. Long answer.
Thanks. Okay, so next, Diana, you have another question. Why don't you if you have a question, Diana, are you there? Okay, so Diana's question is about for example, yeah, you can go ahead because we want to be active participate. Yeah. Oh, you moved now. Yeah.
Oh, you're on mute.
Diana, you are on mute. Okay.
Yes, the 2020 Red Hat conference this week focused on the importance of open source. What impact does this have on the metaverse and edge AI computing? That's my question.
So do you mind repeating the second part? Because on my slide, it cut out.
obviously the importance of open source systems, and what impact does this have on the metaverse and edge AI computing?
Yeah, so maybe I can take that. Okay, so I've been working.
Thank you.
Yeah, because again, there are really, I think, an hidden part to your question, which is open source or standards, or both of them. Okay, and again, let me give at least my perspective. I worked on standard. In fact, even one of the standards is at the foundation of the European Air Traffic Control Management. So for almost 20 years.
Brilliant.
It's yes, really, really. Okay. And at some point, I kind of got a little bit fed up because of mostly two things. The impedance mismatch that there is between standardization and I would say innovation and the pace of innovation in software. Okay. And the second one is the inherent aspect of ossification that are due to legacy and vendor implementing standard and eventually not wanting to change. So my personal view, and I think this is what we're doing also with our company, is that the way forward is absolutely open source for multiple reasons, because is the way to innovate, is the way to make sure that you are completely open. So open with respect to interoperability, open with respect to ensuring that it's fully transparent what you are doing, right? And I think that would be completely open, and open with respect to making sure that you can integrate end user feedback quickly and ensure that end user have more control technology end user in controlling the evolution of your technology. In standard often is vendors who dictate, and end user to some extent, get the consequence of what vendors decided. In open source, I think that the concept of end user innovation and user-driven innovation is much easier to implement and engage if you have a good community. So from my perspective, the key of open source will be essential. And again, this is what we believe. This is actually what we are trying to make. As you know, there are a few important initiatives trying to push try to facilitate edge infrastructure. Red Hat is quite active in this aspect. And one of the elements actually we didn't touch upon yet is security, okay? So, and security from different aspects. Let me at least quote two. One is, once again, recently we had an assessment of one of the technology we implemented that is open source against 7 proprietary implementation, and we ranked by far the best in terms of security. It's an open report from a security firm. So once again, you have the proof that as open source is under the everyone, you have nothing to hide, and you better fix your bugs, right? That still gives better security. Second point is that for anything that has to do with communication, 70% of the exploit come from memory management issues. So even the programming language that we will use for next generation infrastructure, I think it's essential. There is way too much C++ around. And I think, at least in our case, this is where we see the future going, but there are some evidences also for automotive software. Programming languages that are performant and safe, like Rust, will be essential going forward. And this is what we are betting on. And there are interesting signals. Even if you look at the future of automotive, Rust was recently, a working group on Rust was recently announced by AUTOSAR. Automotive is one of the most conservative domain, and they just announced 2 weeks ago that now they have a working group on Rust. And so I think there are multiple innovation coming from open source, and open source will eventually be a big enough wave that on which edge AI will be able to really serve. Thank you so much. That's really impressive. And I started 20 years ago as well, so it's good to share that knowledge. Yeah. Thank you so much. My pleasure, Diane.
Thank you, Diana, Angela. It's a great question and great answer. Okay, so next one, Lidoy, why don't you participate?
Hello, this is Lidoy from Bangladesh. I'm only 24 years old and learning metaverse, NFT, blockchain, a lot of things together. So my question is that we can carry our phone whenever we go out, or we can use our phone while walking. But for VR, we can't use it on road. We need a special place to use it, and also it's a very difficult to carry. I have to take a new bag on my shoulder to carry a VR. So what could be the solution for this?
Are you familiar with Facebook's Aria glasses, or Project Aria, I believe it's called?
I know about a glass called Nubella glass, which is compact and we can carry this, but that is not developed very well. And most of the people are focusing on the VR only. And VR is not a compact device. It's very hard to carry. And most of the people like me, I cannot use my headphone for a long time because it attaches to my head. And VR also is a heavy thing on the head, right? So how can we overcome this solution?
Yeah, well, I think people are not, there's a great video from the Washington Post where a journalist tries to spend 24 hours in the metaverse, and essentially she's wearing an Oculus for those 24 hours. And of course she gets a headache just from the weight of the device. So yeah, this is a clear and a known challenge for the device type. And this is why augmented reality glasses, augmented reality contacts, will likely be kind of the future of virtual reality. So with augmented reality contacts, you could close your eyes and have a virtual reality experience just from, the shutting of your eyes, creating that black backdrop. So yeah, kind of just with all computing devices, they get smaller and more transportable kind of the farther they go. I would say that it's probably just time before the challenge that you're speaking to gets addressed.
Thank you so much.
Yeah, thank you.
And then, by the way, so there is something we are forgetting, right? Because we don't have just hearing and seeing. Of course, we have to talk about touch. How about smell?
Yes.
Right? Don't underestimate smell, because smell is fundamental for evoking memories. When you don't realize, but sometimes you recognize people by smell. You actually, I think we have to be very careful in, we have a fantastic world, and we have 5 senses, or actually more, depending on some latest research. But the point is, I think we shouldn't create a metaverse, which is just a way of escaping the real life, because real life sucks, okay? It should be, I would say, an augmented reality, because there are some good use cases for that. And again, technology should be at the service of the human, shouldn't be used to enslave human or as a way of escaping reality, because your reality sucks, and it's easier to be Djokovic in virtual reality as opposed to train for real. You see what I mean? Because in that we will collectively lose.
Yeah, I think what you're saying is really important, Angelo, that more senses. So I think people often talk about all of these visual devices as the metaverse, but I don't know if I see anybody else wearing headphones, but these are noise canceling in-ear headphones. How are they not augmented reality, right? I'm actually hearing myself and you through a microphone, and it is augmenting my reality through digitization, through computing. And so smell, of course, will be, I see somebody already put that in the comments, probably the most challenging of these things to actually do in a controlled delivery. But all of the other senses are things that we already are doing in many ways, right? People with implants for their heart, et cetera, that's a type of augmented reality. You are working with a device in order to be here in this world. So yeah, maybe you bring up a really interesting point, like what is the conception of reality that we're trying to augment or meta with all this additional technology?
In the ANC, I cannot continue active the ANC for 2 hours. It also makes headache. It's a UX problem in the Apple AirPods, I believe. It also make headache if I use this for 2 hours with ANC activation. But if I use this without ANC, I can use for 5 hours easily.
Yeah, and yeah.
So maybe we'll move to something like Neuralink, where we'll just bypass our senses directly, and we can plug into our spinal cortex, and that'll be the solution.
Well, but see, I that's interesting. I mean, that poses a totally new challenge, which is, both of you both talked about, biology and the human body to a certain extent. I think this jump to wanting to do, even Facebook just recently came out with like a muscle device that can basically feel tiny electrical movements in your muscle as indication of touching a button or wanting to, right, as an impulse, before the cognition of the actual user was, ready to actually say that is what I would have done. So that precognition, we can create devices that are actually aware of our precognition. Like, what does a world look like that computing can act on precognition? It seems, yeah, like jumping the gun perhaps a little bit, but I'm curious what you think of that, Sam.
Wow. We are very in the different level about the sensation, reality, and then we need to touch the brain science.
Yeah. Well,
yeah,
frankly, most of the stuff freaks me out.
Yeah.
But I do see, I do think there are real challenges with the current metaverse, VR technology that, they're not comfortable. They're not, they're not natural. And, just like 3D TVs, right? We all stepped back and just said, just give me a bigger TV. And we do have an ability to immerse ourselves in what we're doing. I mean, when people are playing video games and things like that, whether it's VR or not, they are immersed. And I think we should think about, our minds, the way they work, they will become very focused and immersed without having to completely shut off, other senses and other things, because we will focus on what we're interested in and what we're focused on. So I would say that at least in my perspective, I think that it's more likely that a metaverse not be 100% immersive, that it be something that allows us to engage with it, and yet engage with the real world in a more seamless way. I think that's going to be the winning ticket near term, until some of these other problems of biological interfacing get solved better.
Wow, we can keep going on this great discussion, but unfortunately we are almost time to end. So I will take one more question, and then you can contact the individual speakers, and maybe in the future we have another maybe event similar like this, because unfortunately, because our topic is really fantastic, but a lot of people cannot recognize, right? So we need to share this record and then let them know that how wonderful this topic. So I will take one more final one is Eclipse. I think that I like that final, because I was a great debate this morning about his question is mathematics. Is metaverse equal VR, augmented reality, and question, right? It's a math, right? The reason I raised this question is this morning, actually, one of my LinkedIn connection in the metaverse expert, he mentioned that he put the mathematics, like, for example, metaverse is not equal Web3, because recently a lot of people confuse about like Web3 as a metaverse. And I say that, yes, it's awkward, but it's okay. But I'm also put my math is that the metaverse equal Web3 plus spatial computing plus other AI plus, because it depending on how you build your metaverse, right? So yeah, definitely metaverse is not exactly the VR augmented reality, but the data will be the part of the metaverse. So maybe that maybe there's some answer that to your question. If you have any specific question, you can do it. Eclipse? Not here. Okay, so yeah, we have a wonderful discussion. We can keep going on because we have great speakers, and then they have like in the deep level understanding. So yeah, we can keep going on. But unfortunately, we need to stop now, and then I will pass over to Laura to wrap up.
Well, I think the conversation was absolutely engaging. Thank you very much to everyone for your words and your thoughts. I just invite everyone to participate in a tribe. But probably we should open up a tribe exactly for Edge AI, because it looks and spatial. It looks like that is particularly engaging and leaves a lot of discussion still open. So everyone are invited at TiiQu as participants to the next conversations. Thank you very much to everyone, to Angelo, Kaze Simon, Sam, and of course Alex, and to all participants. Thanks a lot, Alex, for putting together this fantastic conversation.
Thank you, Laura.
Thank you.
Thank you, everyone. Yeah.
Thank you. Thank you.
Bye-bye. Take care.
Yeah,
Bye.
bye-bye. Take care.
Bye.